Welcome to this walkthrough for building product recommender system using LanceDB. This highlights feature engineering tool of LanceDB called Geneva that automates feature engineering at scale. Let's start with some setup and download your dataset. We'll use distributed version, which means we are going to use Kubernetes clusters and nodes to perform feature engineering job in distributed fashion. You can set it to false to perform those jobs locally. So let's start with some setup. You can set the scale based on your environment, some more setup, and then finally I'm going to use this cell to see if I have enough permissions on GCP because I'm going to use Kubernetes clusters on GCP. I'm going to spin those up. These are not required if you're running locally. Again, now I want to set my cluster configuration so that I know what this job knows what types of clusters to spin up. So I have two types of workers. One is CPU and GPU workers, depending on my workload. Then I ingest my raw dataset, which contains ID, description, and image bytes. So I'm going to use LanceDB as object store as well so that I can get rid of all my dataset in the next step. Now I enter a cluster, which basically means that it will automatically scan my local environment and zip it up and upload it to one of those cluster heads so that my local working environment can be replicated across nodes for distributed processing. This magic happens with this command. And coming back to feature engineering, with Geneva, you simply have to define a user-defined function or UDF, and it will be applied to the entire table in a distributed fashion automatically. So you can define row-level stateless UDFs if your job is as simple as adding a tag. Or you can have a batched UDF if you want to perform batch processing, like this occasion tagger that I have defined here. Or similarly, this a product summarizer that I have defined here. So once you've defined your UDF, you can simply register the UDFs like this by just mapping them with a column name. And then you can see that they're registered by printing out the schema. You can see I have my color tags, occasion, and summary string. Now, to actually backfill the features of the table actually has data, you need to perform backfill operations. And backfill operation basically accepts few parameters. We can use batch size and concurrency. And so I'm going to backfill color tags. It will automatically spin up my clusters and perform this in a distributed fashion. You can see the progress here, same with other two features. Now I have this enriched table, but that's not enough for performing search. Now let's create more features on top for embeddings. So we have this batched stateful UDF because we don't want to load models over and over again. So for that, we'll use a class, and this is a slightly different syntax. And then we also request CUDA here because we need to perform model inference. So we'll perform text and image embeddings by using these new UDFs. And we'll create image embedding, summary embedding, and occasion embedding. And the same backfill operation will run again. Now you can see the table is enriched. It has so many more columns now. We'll perform full text index and vector index creation. You can list these indices, and then we'll exit our cluster. Now going to the inference part. You can set up again the same way. And here we'll use a semantic router, which means we'll have a description of the column, what that column represents, and ask an LLM based on the query, choose the right column, which is pretty much choosing the right feature. So that's what we will do here. And finally, hybrid search. We'll perform LanceDB's inbuilt hybrid search using a Cohere re-ranker or Colbert re-ranker, for performing that, so that we also re-rank the results. So putting it all together, you'll see we'll take a user input as a query, and then we'll print out what feature it chose by semantic routing, and we'll then re-rank that and return the top k results, and then we'll display that. So let's look at an example, right? So we have three queries: a black jacket, and the result of a black jacket is it will use the summary embedding because it's a summary, and then we'll see black jackets here. And then a formal tie for business meeting, it should use the occasion feature because we defined an occasion. So now we see this kind of result. And finally, we'll see a tie that would go well with a white formal shirt. This again is summary embedding. So we get those features. So this is feature engineering with Geneva. Thanks for watching.